Okay, now you may be wondering how I actually came up with which term was going to be u and which term was going to be du. It turns out that's a very important decision. Now, in terms of strategies of what I was doing here when I picked them out, is I was trying to pick u so that du is simplified from u. Now, if I pick sine, or I mean rather cosine, to be u, if you take the derivative of cosine, you get minus sine. It didn't simplify any. Whereas I knew that if I took the derivative of x, I'd get 1 times dx, and that's a lot simpler. Okay? So that was the reason. The other thing when we think about v is make darn sure that you can integrate this term. Okay? So, because it's going to be setting right here, and we're going to have to be able to integrate it. So if you pick v to be something you can't integrate, well then this method's going to fail. And in fact, in this example, where it works if we make these selections for u and v, other selections from the same function fail to work because we wind up with this term here being something we can't integrate. And in some cases, many cases, there is no solution for integration by parts for integrating a particular function. It's only sometimes that it works. Okay? So you might worry that, hey, is this only going to work when we have something as simple as u is equal to x? So as long as we got x times something we can, the antiderivative that we can integrate, well then we're fine, but otherwise we're going to be in trouble. That's not quite true, and that brings up the next kind of interesting point in integration by parts.